Welcome to my fourth video. This past year, we have seen attempts to test some flat Earth concepts by conducting experiments. I decided there might be one that I could do with the equipment I already own. I also thought it would be a good opportunity to discuss what makes an observation actually qualify as evidence in support of a claim. I decided to check whether the sun's apparent size really does change, as it must, if it circles above us once a day. Various videos have been offered in support of this claim, but all of the ones I have seen suffer from a lack of precision, usually due to overexposure of the sun in the images. This makes them useless as scientific evidence for anything. They are far too open to having the observer see what they want to see. Documentation was almost always lacking, making further evaluation of the images impossible. My goal was to see if I could make observations that could be considered actual evidence. I wanted to be a little more formal and use the steps we all learned in high school to conduct the experiment. This meant starting with a hypothesis. I settled on what you see here. Hypothesis. Due to the sun's distance changing significantly for an observer during its daily motion in the sky, a telescope's projection of the sun's disk measured at noon will be larger than a projection measured 6 hours after noontime. As you can see, I wrote it assuming the Earth is indeed flat. This was a deliberate choice to reduce my own bias and be more open to accept the result if observation confirmed the change. Also, we have to ask if rejecting the hypothesis can be used as confirmation for the opposing globe concept, or must we wait for other lines of evidence? So I wrote up a procedure ahead of time. Procedure. Using a small telescope and attached flat screen, an image of the sun will be projected onto white paper with a circle drawn for reference. A magnification will be chosen to make the image large enough to be photographed with a digital camera. Once a stable configuration is determined that shows the image, I will place tick marks at the edge of the disk. Observations will be made around local noon and also about 6 hours later. If possible, a control of some sort will be used to show that a single object at two different distances will, in fact, change sizes in the projection. This may prove difficult, as objects not producing their own light are hard to project. A procedure is important so that I could consider what unintended variables might interfere with proper data collection. It is important to try to stay on script and not make random, undocumented changes as the experiment is conducted. These types of changes are seen all too often in videos that make unconventional claims. Here are the pictures I made of the actual observations. On the left is the one made just before local solar noon on June 22nd. You can see the vertical orientation of the main scope focuser. A small finder scope eyepiece is at the top. The weather clouded over, so no evening observation was made that day. I returned on June 24th to make the evening observation, almost but not quite 6 hours later in the day than the first. I can be seen making tick marks on the paper. I used two different sheets of paper, so I would not influence my second set of marks by seeing the first set. I had drawn equal size reference circles to help with alignment and centering of the image on both sheets. Based on a prior test run, I was able to size these circles so that the sun's disk would be just a bit larger at noon. As it turned out, it was larger in both cases. The edge of the sun was sharp, and I was able to see sunspots on both days, so focus was not a question. The left image is actually cut off a bit on the right side, and the right image on the bottom by the limited field of view of the eyepiece. This is because my polar axis was not perfectly aligned, and this telescope has no motor. So I would lead the sun a bit, and made the observations just as it moved into the field, but it was off a bit. The fact that I had the same issue both times actually encouraged me that I was making equivalent observations. So, what did I learn? I acknowledge up front that the observation was not as precise as I would have liked. I should have drawn a line through my circles with tick marks for reference. There is the possibility that the size change was small, but not detected in this test. So this observation could not be used as strong affirmation of a very distant sun. Also note that a true control run with some other object creating an image was not run. However, years of visual viewing of terrestrial objects has consistently showed them to be smaller when they are at greater distances. Since this point is not really in contention anyway, I feel the following result is valid. Conclusion. At my location, the distance to the sun would vary from its closest point at noon to almost double that 6 hours later. This should decrease the apparent size of the sun by about half. This did not occur. The hypothesis is rejected. As a final note, I want to again emphasize as strongly as possible that overexposed, imager saturated pictures with no sharp edge to the sun's disk should have no place in evaluating this claim. The projection method resolves these problems. The projection method is also superior because there is little danger of damaging your eyes or camera. Also, several people can view simultaneously, making manipulation virtually impossible. Thanks for viewing.